I have no special talents. I am only passionately curious. By Albert Einstein. I am Jason Mann. I am someone with passion. I am not a genius or smarter than the average person. I just have an insatiable curiosity of nature. I have always thought of myself as an average person with an extraordinary love for science. I want to share that curiosity, joy of learning, and about the physical world we all share. My goal is to give only the amount of information that is desired, but enough information that piques your curiosity. So join me and let me show you my passion. Hello everyone, it's Jason again, back with another episode of Quarantine Science. Today I'm going to be canceling sound with sound. Now these are the same principles that are used in those noise canceling headphones. What we'll find out, we're not really canceling noise per se, but we are offsetting sound waves with other sound waves. And the way this happens is they take the same sound wave and invert it. And I'll show you here on my screen. What you see are two sound waves. Now this is 500 hertz, and the sample that you see is 2 milliseconds. The upper channel will be the left channel. The lower channel will be the right channel, or the right speaker. And I have two speakers set up here. And this program is an oscilloscope which has a little bit of hardware attached to the speakers, which, as you see on the right, emits a voltage signal. And over time that voltage signal fluctuates. That fluctuation drives the speakers to move in and out. Now currently I have them set up to be identical. And by identical I mean they're in phase. It's the technical term. And what happens is if I play the audio here of just 500 hertz, you will hear the tone, the 500 hertz tone, fairly distinctly. Now, we can think about this as a position of that speaker in time. The cone of that speaker will move in or out. And with both of them working in tandem, they will actually increase the sound. And if we were to offset or phase shift the pattern, the frequency, what we actually do is we shift that sine wave, we actually flip it upside down, it's inverted, and therefore one of the speakers will actually be pulling in as the other speaker is pushing out. Now this happens 500 times a second, so it's very hard to see. But the effects of it is that it's just pushing the same column of air back and forth and not really creating a pressure differential. One is kind of catching that air as the other one is pushing that air. Think of this as two lumberjacks working the saw back and forth. When they're working in tandem, it appears that nothing is happening. But if they were to try to push the saw blade together at the same time, that's when you get that flex, and that's when that speaker would move out, right? That's when you hear the sound. So here we are with a inverted sine wave on the bottom, and this is going to be the second speaker, the speaker on the right. And as you hear, I'm playing the sound now. You can barely hear anything. In fact, I'll turn the speakers around and you can kind of hear it. This is that noise cancellation. Now, if we were to put them back in phase, and here it is in phase, just to show you it's not smoke and mirrors. Now they're working together, producing a sound at 500 hertz. And if we're to turn them back, as you notice, not a lot change occurs, But if we go back to a different phase, let's say 90 degrees, we notice that the sound decreases a little bit. Now they're not working in phase, and they're not working exactly against each other either. But that same thing, that 180 degrees, and we get that cancellation. Now this holds true for your regular speakers on your stereo. I'm going to carry this same experiment out to my TV. So let's head out there now. So now we're at the TV, and I've tapped into just one channel, the left channel. Apparently on this program, which is a 90s sitcom, they ran their laugh tracks on the sides of your stereo speaker, and you get very little voice track coming through either the left or the right channel. Currently you can hear it though. And if I were to set the speakers together, you still hear it. It's a little muffled only because the sound is having to reflect off of the other speaker, which is not moving, by the way. But what I've done is I've set up a wire which is running over to the other speaker, but instead of going from positive terminal to positive terminal, I have fed in that wire to the negative side. And this is what you call reverse polarity. Reverse polarity works in the same method as a phase shift, 180 degrees phase shift. And here we go. Apparently I'm not that funny anymore, because now still don't hear a lot of noise coming out of it, but the program is still going. There you go, and there it is. Phase shifted or reverse polarity has that same effect. So you can actually do this at home with two speakers coming out of one of the channels. Now, if I were to put these in correct phase, you would see that not only does it play the sound correctly, it actually amplifies the sound. That amplification is at a certain decibel level. If they're being played in sync, it would be 3 decibels above the typical decibel for one. I'll get more into that in a longer discussion over on my YouTube page, but for now, just want to keep this video short and show you something pretty neat today. I hope you did find it fascinating. Comment in the section below. Let me know how you liked it, didn't like it, what I could do better. But otherwise, I will catch you on the next one.